Good morning, students. Yesterday we have studied about the physical quantities, units of physical quantities, system of units used for measuring physical quantities, etc. Right? How many types of physical quantities there? Base quantities, what is called fundamental quantities, and also derived quantities. What are fundamental quantities? Fundamental quantities are quantities that does not need any help from any other quantities for their specification. They are independent of each other, right? While derived quantities take the help of fundamental quantities for their specification, right? So derived quantities, in fundamental quantities, we have 7 fundamental quantities are called base quantities and 2 supplementary quantities. Which are the supplementary quantities? They are plane angle and solid angle, right? And the derived quantities are many derived quantities out there. Most of the quantities that we discuss in physics are derived quantities only. For example, displacement is a derived quantity, right? Velocity is a derived quantity. Acceleration is a derived quantity. Force is a derived quantity. Work done is a derived quantity. Power is a derived quantity. Linear momentum is a derived quantity. Torque is a derived quantity. So many derived quantities are there. Yesterday we have studied how we can frame the unit of physical quantities using the different systems. 3 systems also we have discussed. One is CGS system, other is MK system, and other is SI system. Since modern times, we use only SI system of units, right? To measure both fundamental quantities and derived quantities. So derived units are the units that we get with the help of fundamental units. For example, force, I said, force is kg meter per second square. How we got it? Because in this case, the unit of mass is force is equal to mass into acceleration, right? That is equal to m into a. A means acceleration. Acceleration is velocity with time, right? So acceleration, the unit is what is called meter per second square, and the unit of mass is kg meter per second square. So we got the derived unit of the derived physical quantity force, right? That is an SI unit. So your derived unit of force is equal to mass into acceleration. Mass is measured in terms of kg, and acceleration we have discussed, that is equal to velocity by time. Velocity is equal to displacement by time. Therefore, displacement of time square. Displacement is meter and time square line. So we got kg meter per second square, because time is in second. This is the unit of this quantity force. What is force? Force is a derived physical quantity. So any derived physical quantity also we can obtain the unit in terms of the unit of fundamental quantities. kg is the unit of fundamental quantity. Meter is the unit of fundamental quantity, and the second is also unit of fundamental quantity. Using the unit of fundamental quantities, we can obtain the unit of derived quantities. So this is the SI unit of force. So likewise, all derived quantities that we discuss have the units. Those units are in the SI system. For example, work done we can take. Work done is equal to force into displacement. Force, the unit, that is what's called kg meter per second square into displacement. Displacement is in meter. Meter into meter is equal to meter square. Therefore, kg meter square per second square. This is the derived unit of work done. SI unit of work done. Right? SI unit of work done because all the units of fundamental used are SI units only. kg is the SI unit of mass. Meter is the SI unit of length. And the second is the SI unit of time. So this is how we have studied about the unit of all physical quantities, whether it is fundamental quantity or it is derived quantity. right? So, and also we have studied in the last yesterday about the advantages of SI units. That also you have to study very well. And one more thing, what I want to do, what I want you to do at home is, you have to write in your notebook the definitions of all fundamental quantities. All fundamental quantities, 7 fundamental quantities are there, starting from meter. Meter is the unit of length, right? Meter you have to define, mass, kg you have to define, and second you have to define. Like that, 7 fundamentals you will define, right? So that definitions of all the fundamentals, 7 fundamentals you will write in your notebook. Then only the first chapter will be completed. After completing the first chapter, we have another topic, what you call dimensional analysis. Dimensional analysis means any physical quantity, derived quantity, or a fundamental quantity can be expressed in terms of the units of those. For example, for this topic, the units of length I will take as capital L. And unit of mass I will take as capital M. And unit of time I will take as capital T. Using L, M, and T, length, mass, and time, apply some powers with these units, we can represent any physical quantity, whether it is fundamental or it is derived. Such a way, when we represent a physical quantity in terms of the units of fundamentals raised to some powers, is called dimension or dimensional formula of the physical quantity. So dimensional formula of a physical quantity is the method of representing a physical quantity with the help of fundamental units raised with certain powers. So this is what is called. For example, we have area. Area is a physical quantity. Why area is a physical quantity? Everybody knows. Because area can be measured. All measurable quantities are physical quantities. Those quantities we discuss in physics are all measurable. Hence, those quantities are called physical quantities. Physical quantities can be fundamental quantities, also can be derived quantities. Every fundamental quantity has its own unit, and also we have the units for derived quantities also. Right now, irrespective of fundamental or derived quantities, we can represent these physical quantities in terms of some powers applied to fundamentals. That is what is called dimensional analysis. Now, the first quantity I am taking up is area. Suppose area of a rectangular field or a rectangular cardboard, right? Area is equal to, we can write length into breadth, we can write. Length into breadth. Length is measured in length only. Length is a length, the breadth is also length. Right? Breadth is also a length only. This also a length only. Therefore, the unit of this we can write, this is L, and this also L. Therefore, this is equal to L square. Not enough. This is not the dimension. When you write dimension, at least 3 units must be included. So, dimensional formula of area is equal to M raised to 0, L square, T raised to 0, you will write. This way, when you write, this is called a dimensional formula of the physical quantity area. Am I correct? So in this case, what we are doing, we are representing the physical quantity area in terms of the fundamental units, mass, length, and time, with some powers applied to it. In this case, you will read the dimension of area is 0 in mass, 2 in length, and 0 in time. This is the way how you read it. Once again, the dimensions of area are 0 in mass, 2 in length, and 0 in time. So this way, when we represent a physical quantity, this is called a dimensional formula. When we write in the form of an equation, that is called dimensional equation. For example, dimensional equation I'm writing, this is K. K is the symbol of area. Area is equal. This also in square bracket only you will write. That is equal to M raised to 0, L square, T raised to 0. This is the dimensional equation of the physical quantity, what you call area. Other than I am going to tell you about volume. Volume is also another physical quantity. Any physical quantity, whether it is fundamental quantity or it is derived quantity, we can write in the form of dimensions. The method of writing or representing a physical quantity in terms of the units of fundamental quantities raised with the powers is called dimensions of that physical quantity. Now I am talking about volume. Volume is equal to what is called length into breadth into height. The length into breadth into height. Right? Length is measured in length only. Right? It is a fundamental quantity. Height is also a length only fundamental quantity. And breadth is also a length fundamental quantity. Height is also length fundamental quantity. Therefore, we can write this is equal to L into L. That is equal to L cube. Not enough. We have write the dimension of the physical. Dimension must have at least 3 quantities included in that. So dimension of physical quantity is equal to m raised to 0 because mass is not there. M raised to 0 is any quantity raised to 0 is equal to 1. So m raised to 0 multiply with that, then that does not make any difference in the value of L cube, right? So m raised to 0, L cube into T raised to 0. So this is the dimensional formula of volume. Right? How is it read? This is read as 0 in mass, 3 in length, and 0 in time. So this way, when a physical quantity is represented in terms of the units of fundamentals raised to the certain powers is called dimensions. I think you are following me, right? Dimensional equation when we write, how we can write? That is, V means a big V, means a big letter V, capital letter V, that is in the square bracket. Then you will write m raised to 0, L cube, T raised to 0. See, any quantity, physical quantity can be represented in terms of fundamentals raised to certain powers